Okay, this starts the back side, page 2 of your review worksheet for Chapter 7a. So I've got to solve this equation by completing the square. So I'm going to add 5x squared to both sides. And I have a minus 10x, and then I'm going to subtract 3, getting it in standard form. I'm going to divide by 2 every term on both sides and cut that down. So I have x squared minus 5x. This is going to be a plus 8, but I'm going to leave it as blank and subtract 8 minus 8 minus 8 from both sides, and leave a blank to complete the square on each side. Now I'm going to take half of negative 5, which is negative 5 halves, and I know I want to build a trinomial that's x minus 5 halves times x minus 5 halves, and I'll write it here. And so to do that, the term here that I have to add would be the square of negative 5 halves, which is 25 fourths. So I have to add 25 fourths to both sides. So now on the right side, to simplify, I'm going to add negative 8, which is negative 32 fourths, with the 25 fourths, and that gives me a negative 7 fourths. So now taking the square root of both sides, positive or negative square root of negative 7 fourths. So I can see that this is the same as square root of negative 7 over square root of 4. So I'm going to get a rational 2 in the denominator, because this is the same as, I root 7 over 2, because the square root of 4 is 2. So I've got, I'm going to add the 5 halves now. So x is equal to 5 halves plus or minus I times the square root of 7 all over 2. And I could write this 5 plus or minus I root 7 all over 2 if I wanted as well. This represents two solutions, the plus path and the minus path. Okay, so now number 18, again, completing the square. I'm going to have a 5x squared. I have to subtract this x to get this equation set equal to 0. So minus 4x minus 12 equals 0. So if I had my choice, I would probably try and factor this. It looks like it would be factorable, but I don't. So I've got to use all the steps for completing the square. First of all, a has to be 1. So I have to divide out the 5 by every term on both sides. So now I have x squared minus 4/5 x plus blank to complete the square equals. I'm going to add 12/5 to both sides. This, of course, is a 0. So I'll have a 12/5 plus blank to complete the square. So half of negative 4/5 is negative 2/5. Right? Half of 4 is 2. So that's even. So I get x minus 2/5 quantity squared. So when I write the trinomial that is, I'm going to square that negative 2/5. So I'll get 4/25. It has to be added on both sides. Okay, so on the right, this 12/5 I have to write, I have to multiply by 1 in the form of 5 over 5. To make that over 25ths. So 12 times 5 is 60. So I have 60 25ths plus 4 25ths. Conveniently is 64 25ths. Both perfect squares. So now taking the positive and negative square root of both sides, this expression comes out equals positive or negative square root of 64 over 25. So you can probably see that this is going to be an 8 over 5. So I'm going to add the 2/5 to both sides. X is equal to 2/5 plus or minus 8/5. So on the plus path, I get 2/5 plus 8/5, or 2 plus 8/5, which is 10/5, which is 2. On the minus side, I get 2/5 minus 8/5, or 2 minus 8 over 5, which is negative 6/5. So on this one, my solution set is a positive 2 and a negative 6/5. So because those are rational, I know it could have been factored, but I didn't have a choice. I was asked to do this by completing the square. Okay, next we're using quadratic formula on number 19. So I'll get everything on one side. If I add 9x squared to both sides, I'll just have a 1x squared on the left. If I subtract 12x from both sides, I'll have a positive 12x on the left. Minus 18 is 0. So in this, A is 1, B is a positive 12, and C is a negative 18. So quadratic formula, the x will be equal to the opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 18, all over 2a, 2 times 1. So continuing to simplify, negative 12 plus or minus, this is going to be a 2. So under the radical here, I'm going to have 144 is the 12 squared, so 144 minus a negative 72, so plus 72. So 144 plus 72 is square root of 216, which if I take the square root of that, does not simplify. So let's break down that 216. It's 2 times 108, which is 2 times 54, which is 2 times 27, which is 3 times 9, which is 3 times 3. So I have a 4 in there and a 9. So I have a 2 times 2 times 3 times 3. I have a 36 times a 6. So a 6 comes out and a 6 stays in. So x is equal to negative 12 plus or minus 6 times the square root of 6 all over 2. So pardon the dog. Somebody rang the doorbell. Anyway, so I have a common factor here and here and here. So I've got a common 2 in all of those. So I'm going to have x is equal to negative 6 plus or minus 3 root 6 as my final answer. So that's two answers, negative 6 plus 3 root 6 and negative 6 minus 3 root 6. Okay, so then for number 20, quadratic formula, adding the 2x to both sides, plus 12x plus 8 is 0. In this case, A is 5, B is 12, and C is 8. So we get x is equal to the opposite of 12 plus or minus the square root of 12 squared minus 4 times 5 times 8 all over 2 times 5. X equals negative 12 plus or minus. So the 12 squared there is going to be a 144 minus 20 times 8 is minus 160. So that is 16, negative 16. So plus or minus the square root of negative 16. So I can tell I'm going to have imaginary roots all over 10. So that's going to be a 4i that comes out here. So x is equal to negative 12 plus or minus 4i all over 10. My common factor of 2 is in the triangle here. So I'm going to factor out that 2 to get x is equal to negative 6 plus or minus 2i all over 5. And yeah, so negative 6 plus 2i over 5 or negative 6 minus 2i over 5. All right, now I get to use the method of my choice on these. So with number 21, first of all, I'm going to move the 6x over, minus 20x plus 36 equals 0. Well, let's see, 3 times 12 9 times 4, 18 times 2. This is easily factorable. To check that, if I found the discriminant, b squared minus 4ac, I would find that it was a perfect square, and that would tell me it was factorable, or if it was 0. So this is going to factor to x minus 18 times x minus 2. So my solutions are a positive 2 and a positive 18 for this. Okay, number 22. Let's see, well, oh, I've got an x squared here and an x to the 4th here. So if I rewrite this as 11x squared, I notice that I have that same function of x, that same expression, x squared, that's here as a squared term with a coefficient of 2. So this is 2x to the 4th, which is the first term, plus 11x squared plus 12 is equal to 0. So I'm going to use the substitution method and temporarily let u represent x squared. So I can write this as a simpler equation, 2u squared plus 11u plus 12 is equal to 0. So let me see if I might be able to factor this. I can't divide out anything, so let's go 2u and u. If I put a 4 here and a 3 here, I've got an 8u and a 3u, which, if they're positive, can combine to be the 11u in the middle, and then a plus 12. So u is equal to negative 3/2, or u is equal to negative 4. So now, I wasn't supposed to solve for u, that was just temporary. Now I've got to put in my original player, x squared. X squared is negative 4. So on the left side, I'm going to take the square root of both sides. So x is the positive or negative square root of negative 3/2. I'm going to borrow some space over here to continue with this. I have to rationalize that denominator, so I'm going to pull this out and multiply by 1 in the form of 2 over 2. So I'll get the square root of 4 in the denominator, so I'll have a 2. So x is equal to positive or negative, so I and root 6 over a rational 2. So that's two. Those are two of my roots. I root 6 over 2, positive I root 6 over 2, and negative I root 6 over 2. Now with this one, x is equal to positive and negative square root of negative 4. So that is going to be x is equal to positive or negative 2i. So there's my 4 solutions. Positive 2i, negative 2i, positive I root 6 over 2, and negative I root 6 over 2 for that problem. Sorry, I got squished up. Okay. So for this one, number 23, I notice that I have an x under the radical, making this a radical equation. I could solve it by isolating this term, getting the 2x and the 15 on the other side and squaring both sides the way we've done in previous chapters. Or I could say, I notice that this function of x, this square root of 2x, is squared over here. It appears there squared. So if I'm going to rewrite this 2 times the square root of 2x, I can see that square root of 2x, the whole thing squared right here, because when I square this, I have a 2x. So it's like the coefficient to that is just a 1, and then the coefficient to this is a 2, minus 15 equals 0. So you can probably see that I'm going to do this with the substitution method, temporarily let u represent the square root of 2x, and write a simpler equation. So I'll have u squared plus 2u minus 15 equals 0. Well, easily factorable to be positive 5 and a negative 3 plus 5u minus 3u. So that works. So I get u is equal to a 3, or u is equal to negative 5. Okay, so now I have to substitute back square root of 2x. So square root of 2x, which was temporarily being represented by u, is equal to 3, or square root of 2x is equal to negative 5. Now remember, you're going to have to check for extraneous solutions on this, because when you square these and you're squaring negative values, you can get an extraneous solution. So to solve this, I'm squaring both sides. So I get 2x is 9. So x is 9 halves, which is 4 1/2. On this one, squaring both sides, I get 2x is 25. Because when I square the negative 5, I've got a 25. So x is 25 halves. Okay, so let's, I'm going to carve out some space here. Actually, I think I'll just go to a separate sheet to show the check step on that. Let's see. Oh no, please no. Lillian, stop. Okay, so in the original equation, 2x plus 2 times the square root of 2x minus 15 equals 0. If I'm going to check it first with the 9 halves, I'll say 2 times 9 halves plus 2 times the square root of 2 times 9 halves minus 15 equals 0. So that cancels, so this is a 9. That cancels, so this is the square root of 9, which is a 3. So 2 times 3 is 6. So that's a 15 minus 15 equals 0. So that works. So the 9 halves works. And then I'm checking the 25 halves. So 2 times 25 halves plus 2 times the square root of 2 times 25 halves minus 15 equals 0. So here those cancel. This is 25 plus, so that cancels, and this is the square root of 25, which is 5. 2 times 5 is 10, and then a minus 15 is 0. So this is 35 minus 15, or 20, so that doesn't work. So that means that I have to reject the 25 halves. It's an extraneous solution. So my solution to this problem is just simply a positive 9 halves. Okay, number 24. I get to use the method of my choice, 9x squared minus 8x plus 8 equals 0. So because a is not 1, I don't want to divide every term by a to use the completing the square. So I'm just going to use, this might factor, but I'm going to use quadratic formula, I think, for this. Yeah, so anyway, a is 9, b is negative 8, and c is positive 8. You have to make sure a, b, and c that you've got the other side set equal to 0, otherwise you don't really have the equation in standard form. So anyway, x is the opposite of negative 8 plus or minus the square root of negative 8 squared minus 4 times 9 times 8 all over 2 times 9. So x is equal to 8 plus or minus the square root of something all over 18. So when I go to simplify this, I'm simply going to punch it in here. So negative 8, when I square it, I have the whole negative 8 being squared. I get 64 minus 4 times 9 times 8. So 64 minus 4 times 9 times 8 going to be a negative 224. So I tried taking the square root of that, and it is not a perfect square, so I have to factor out that 224. I know I'm going to have an I come out. So this is 2 times 112, which is 2 times 56, which is 2 times 28. Whoops, I went dark. 2 times 28, which is 2 times 14, which is 2 times 7. So this is a perfect square, 4 times 4. So I have a 16 times 14. So this is 16 times 14. So 14 will stay in. And a 4 will come out, I think. 56, 2, 28, 2 times 14, 2 times 7. So I get x is equal to 8 plus or minus 4i, because the 16 square root comes out and the I, and the 14 stays in, all over 18. So I do have a common factor of 2 in my triangle here, in the rational terms. So if I factor that out, I get x is equal to 4 plus or minus 2i root 14 all over 9. And I'm checking my answer, and I guess that is correct. 4 plus 2i root 14 over 9 and 4 minus 2i root 14 over 9. Kind of a messy, messy problem. Okay, so moving along. Okay, so number 25, one of the things you can do is, you know, if you really quickly just want to figure out the discriminant, just punch it into your calculator. So I can say 28 squared minus 4 times 5 times 32. And I get 144, which is a perfect square, telling me that I can factor this. So that's kind of a quick check, if you ever wonder. So 5n and n. So I got to get a 28. So 32, I have a 1 times a 32, a 2 times a 16, 4 times an 8. So if I use a 4 here and an 8 here, I can use a 20 and an 8, 20n and 8n to make a 28n, and those are both positive. So that looks good. So my solutions are negative 8/5 and negative 4. And I can check those on my calculator if I needed to. Okay, number 26 is easy because this one just has a squared term and numbers. There's no x term. There's no linear x. So I'm just going to add 2 to both sides. So plus 2 is a negative 5. And then isolate the x squared so I can take the square root of both sides. Just using, this is the square root method. So dividing both sides by 9, x squared is equal to negative 5/9. So x is equal to the positive or negative square root of negative 5/9, which is going to be a rational 3 in the denominator and an I root 5 in the numerator. So x is equal to positive and negative I times the square root of 5 over 3. Okay, 2 roots. I root 5 over 3 and negative I root 5 over 3. Okay, number 27 causes some confusion because kids jump in and just see the square root and they think, oh, I'm going to, you know, I'm going to isolate that and square both sides, or I'm going to use this like, you know, the square root of this as a function of x and look for it squared over here. But this is just a number. It's really 2 times x times the square root of 3 is really 2 times the square root of 3 times x. I just don't like to write the x after the radical because you can't tell if it's under it or not. So I'm going to rewrite it because that is like the coefficient. 2 root 3 is the coefficient to the linear x term. So this is 2 root 3 times x minus 3 is 0. And then I'm going to use quadratic formula to solve this. So a is 1, b is positive 2 root 3, and c is negative 3. So x is equal to the opposite of b, which is 2 root 3, plus or minus the square root of b squared, so 2 root 3 squared, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times 1. So x is equal to negative 2 root 3 plus or minus. Now, this is, how is this going to simplify? 2 squared times root 3 squared is 2 squared is 4 times 3, so that's a 12. And then we're subtracting a negative 12 here. So we're adding 12. So this is really the square root of 24 all over 2. So 24 has a perfect square of 4 in it. So a 2 comes out and a 6 stays in. We get x is equal to negative 2 root 3 plus or minus 2 root 6 all over 2. And this can be simplified further because I have in my triangle here the rational parts in all the terms, both terms in the numerator and the term in the denominator, a common 2. So if I divide that out, I get x is negative square root of 3 plus or minus the square root of 6 all over 1. So negative 3 plus root 6 and negative 3 minus root 6. Okay, last one, number 28. I see I have an I here. The 2i is actually the coefficient to the x. I'm going to recopy this. Plus 2i, that's like the b, times the linear x, minus 1 is 0. So a is 1, b is 2i, and c is negative 1, and I am using quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x is equal to negative 2i plus or minus the square root of. Now, when I square the 2i squared, I get 4i squared, which is negative 4. And then this is going to be minus 4 times negative 1, so it's going to be a plus 4 all over 2. So continuing here, negative 2i plus or minus square root of 0 over 2. So the square root of 0 plus path and minus path are the same. Either way, I have negative 2i over 2 or negative 2i over 2. So it's a double root. And we can see that these are both just the negative i's. So my solution set on this is just a negative I, because when I cancel the negative 2 over 2, I get a negative 1i. It's a double root. I'm going to put, double root. So anyway, that's it, really. That's the whole worksheet. So good luck, practice, and good luck on your test.